Okay, let's solve a new problem today. 3 sum. 3 sum. Given an integer array nums, return all the triplets nums I, j and k such that I is not equal to j, I is not equal to k, j is not equal to k. So all the three are 3 different indexes, and the sum of the 3 items kept at those indexes is 0. Notice that the solution set must not contain duplicate triplets. Sure. Let's take this example. Nums is -1 0 1 2 -1 -4. So -1 -1 2 -1 0 1, and sure, because the sum of the 3 elements in all of these arrays is 0. Only possible triplet does not sum 0. Okay, we have to return empty array if we do not find any triplet that sum up to 0. Fine. And because we have to finally play around with 3 indexes, so if we go with brute force, that is grab all the 3 possible items in the array, the time complexity is going to be n cube, right? And size of the array is 10 to the power 3. So n is 10 to the power 3, n cube would be 10 to the power 3 to the power 3, that is 10 to the power 9. Okay, so it will result in TLE. Still, let's give it a try. Brute force. Okay, now in brute force we can grab all the 3 items. Okay, we'll keep on checking if the sum is 3. We'll keep on adding it in the result set. Let's just solve it and we'll see. So brute force. So let's first create a result set. All the stuff, and so this is what we are going to return. And we just iterate through this array three times. Right, and we check if nums of I, nums of j, and nums of k, if this is equal to 0, that means we have found a contender in the result set. The question says, notice that the solution set must not contain duplicate triplets. So if let's say the first triplet we found is 1 0 2, we should not keep 2 0 1, right? If we have 1 0 2 and the second triplet is, because duplicates are allowed, right, in this array, so we have found 2 0 1, still it will it be considered as a duplicate triplet? Duplicate triplet, technically it should be, because the 3 elements in the first triplet and second triplet are the same. Yeah, yeah, sure. So in order to test this, do we have to keep it in? We would have to check this, right? Every time we find that sum of, okay, these 3 elements items is 0, we would have to first check if we already have these 3 items added in the result set. If we have already added these three triplets in result set, then we do not have to add it again. We'll see. Let's keep things simple first. So here, because we have found first contender for the result, we'll create a list, triplets, and we are going to insert all of these. I think there's an easier way to do this. We just do this. Nums of I, nums of j, and nums of k. Right, we have this triplet. For now, let's not think about that. Solution set must not contain duplicate triplet. We'll come to that later. Result dot add triplets, and we return our result. For less than length, if the sum is 0, we store it, we add it here. Okay, let's run this. Syntax error, sure. Let's see. So the output, and this is what was expected. So this is duplicate triplet stuff, right? Case 2, because there were no duplicates. Okay, this was just empty. That's okay. And this was just one item. But here you can see that the first and the last one, okay, both of them are same. They are duplicate triplets, and that's why it is not there in the output. So let's consider that now. Now, one of the easiest way to maintain duplicate triplets would be to keep a hash set. Let's think. What are the different ways to check if the three items has already been added to the result set? One of the easiest one would be we grab those items, maybe sort them or something. Yeah, sort them and concatenate them. We have a unique string, keep it in hash set. Is there any easier way? Nums I, nums j, and nums k. If we are using hash set of three numbers, that is one way. Another way, no, dictionary will not be that good. We just have three items. We sort these three items. Yeah, let's go with the easiest one. Okay, where I'm saying, let's say we got this, we are going to sort this 0, 1, and 2, and then maybe we are going to convert it into a string, concatenate it like this, and this is our string. We keep it in a hash set, kind of a dictionary without values, just keys are there in hash set, right? So for this one as well, we'll sort it 0, 1, 2, convert it into a string, and insert it in the hash set. Let's try with this. So, so sorted result is any problem with the index? I mean syntax. Okay. So we have kept the three items in an array. Now we are going to sort this array, and the result array dot sort sorted results. Okay. And then we are going to concatenate. So string key is equal to, it will always have three items, right? And we know sorted result 0, sorted result 1, and sorted result 2. Right, we have this key now, and then we keep a hash set of string, right? um, Unique triplets, new hash set of string, and unique triplets dot add this key. And before adding it, we're just going to check, sorry, we're just going to check if this triplet key contains this key. So if it does not contain this key, that is the only scenario when we would like to add this in our final result set, right? Otherwise we do not want to add it. Okay. uh, Unique triplets dot add, and keep on adding it, because even if the key is present, if you try to add the key again in the hash set, it will not add the key, but it will not throw the exception as well. Contains key, to make things simpler and more, little more efficient, we can actually do this if is not otherwise. So if it does not contain this key, then we add the key in the hash set. Yeah. And we continue from there. So in this way we will be avoiding that to list. We'll make things simpler. Let's just see if this solves the problem. Okay, it did solve the problem. uh, Creating memory for list and then array. Yeah, let's make it a little more better. So we have this array, right? Sorted result. Okay, but then array is going to get sorted. I was thinking, what if we just use this sorted array, just do dot to list and add it in the result? Will the order of the triplets matter? Most probably it will not. We'll see. So I'm saying we do not need this list. We have this array. What we do is triplets is sorted result dot to list, and just add it in this result set. Most probably the order should not matter, I'll say. Yeah, it did not. Cool. But it will result in TLE, because 10 to the power 3 to the power 3. Let's submit this and see if we get a TLE. We should. There we go. 308 out of 313 test cases passed. That is nice, but let's find a better technique. So a method with better time complexity. Let's try to understand this problem. A little better. Little better time complexity. So we have to find out triplets that sum up to 0, 0. What if I sort the input array? So saying, if we take this example, that is -1, let me remove all of this. So I'm saying we have -1, 0, 1, 2, -1, and -4 as the input array. If we sort this, it will be -4, -1, -1, 0, 1, and 2. Right. Now I'm thinking something like you have you're going to get a large item here, sorry, a very small number here and very large number here, and okay, we still need a third item. If it was just two numbers adding to 0, let's think, if it was just two numbers, we have to find not triplets but a pair that add up to 0. We could have done something like this: just sort it, start the first index from here, that is the leftmost end that has the smallest number, and the rightmost end that has the largest number, and add them together. Okay, so in this case we have -4 and +2, that is -2, right? So we know that to get to 0 we are little behind it. We need a larger number, right? So so one possibility was, let's say this number is a and this number is b. So a plus b, either it is going to be greater than 0 or it is going to be less than 0. If it is going to be greater than 0, we want the sum to reduce, and if it is less than 0, we want the sum to increase so that it is going to get to 0, because our end goal is it should be equal to 0, right? So in this case, because -2 is less than 0, we want the number to increase, right? So there's no point in you know moving this index to the left, because that is just going to reduce the number that was higher, because we know the right end is always going to be higher because this is sorted. This is a sorted array. So because we want the pair, the sum of the pair, the value of the sum of the pair to increase, we would want to move our left index little to the right. So in this case, -4 plus 2 will move to -1 plus 2, that is this index and this index, and that will add up to 1. So now we are ahead of 0, so we would want to reduce our overall value. So in order to reduce, we should reduce the higher number, right? We should go little to the left of the right index. So we would have remove this, we have got to this point, so this stays as it is. So our left index -1 stays as it is, our right index is now 1, and we have got to 0. So this was a good flow to solve two sum problem, right? But here we have a three sum problem. You know what, we can extrapolate our two sum problem into a three sum problem, because we know two pointer approach can solve two sum problem. Three sum problem is just one extra element. What if, let's say, let me change the color, the band, I like green, okay. So what if this is our array, we do a normal for loop iteration, the first index, second index, up to so on. So that is where we grab our first item out of the three in the triplet, right? So let's say the value of first item is -10. Okay, normal for loop iteration. And then we are left with wherever we are, let's say the current index is I. So from I plus 1 till the end of the array, that is n minus 1. This is an area for two sum problem then, because 3 sum is equal to 2 sum plus one extra element. So every time we just iterate through it, we know that current value is -10. So we know that a plus b plus c should be equal to 0, and we know the current value of a, so it is -10. So what we want is b plus c should be equal to 10, right? So the two sum problem where we were saying we have to find two elements that sum up to 0, that gets changed to we have to find two elements that sum up to a fixed number, a specific number. But still the overall idea stays the same, that we have this array, sorted array. We start from the left end and the right end, and we add these two number. Let's say this is b and this is c, right? So we add these two number b plus c, and we see the whole concept stays as it is. Just replace these zeros with that number. So in our case, because a was 10, b plus c should be equal to 10. So uh, let's say here, because it is written a, ignore this. So we have two numbers b and c. B plus c should be equal to 10. So change this 0 to 10, and this is 10, right? So overall concept stays the same. If the sum of the two number is less than 10, we want to increase the number, and if it is greater than 10, we want to decrease the number. Okay, let's try to understand the time complexity of this problem, because this is good, this will work. Yeah, let's understand the time complexity. So this is our array. We are doing a normal for loop to iterate through the first element, so that we have one element always with us, and we convert this three sum problem into a two sum problem. And then we are left with remaining numbers, where we have to do two pointer approach. Two pointer approach is just linear iteration. So the complete, so iterating through the first element is n time complexity, and for every element we have to do two sum problem. Two sum problem is linear iteration, so n. So this is n squared time complexity. The size of the input array that is given to us in this problem is 3000. So 10 to the power 3, 2 is 10 to the power 6. So time complexity, it will not result in TLE. Okay, so we know that it will work. Let's try to solve this problem. Let me clean this up. Reset to default definition. Okay. So three sum problem converting to two sum problem. Let's say this is our result, which we are going to return. You know what? Three sum problem converting to two sum problem. Okay. The hash set stuff, that was duplicate. We still would need that. You know what? Let's keep few things with us. The result unique hash set, and I'm going to do some copy paste from the above thing. I'll just write the solution here. I list of int, and this is three sum. Second technique, that is n squared time complexity. So I'm saying we use result and hash set. These two are going to stay the same, because we still want to avoid duplicates. Now we iterate through this, our first iteration to grab the first element out of the three in the triplets. Num start length I plus plus. You know what, at first we have to do sorting, right? We have to sort it first. array dot sort nums. Array dot sort is going to sort it by default in ascending order, so that's good. Now I is equal to 0, I is less than nums dot length I plus plus. We have the first element. Now let's do a two sum problem now. So our left index in the two sum problem is I plus 1. Our right index is nums dot length minus 1, and left and right we have to move towards each other, while left is less than right. Right, yes, yes. Let's see. If nums of I are primary element, nums of left, what we do not have to again and again consider nums of I and nums of left. We should do int number, which we have to the sum of the two numbers, that pivot number we are going to see. So here the sum was a plus b plus c is 0. B plus c should be equal to minus 1 times the initial number, right? Okay, so we are just going to do minus 1 times nums of I. So this is our number. Now we are going to do if nums of left plus nums of right is greater than this number, if the overall value is greater than this number, we have to reduce the value. So we have to go right minus minus. We are currently at a higher value, we would have to reduce the value, so move the right end little to the left. So we have to do right minus minus. Else if nums left plus nums right is less than number, we have to increase the value, so do a left plus plus. Okay, now a good question would be, what if nums left right is equal to? So else if they are equal, then this is a contender, this is a triplet which we can add to our result, provided we have not already added it. So here we have to do all the hash set things which we did. That is, okay, these are the three numbers. Okay, they are already sorted, so we do not have to do this. Create a key and check all of it. Fine. So we are going to do and a result nums of I, the first one, nums of left, the second one, and nums of right, the third one. They are already sorted. We just have to check the key, that is, let's create a key and we check if, what is the name of the hash set? Unique triplets. Unique triplets dot contains this key. If it does not contain, that is when we are going to add it in our result. Result list is result dot add, and we should change the name triplets. Okay, it is already sorted result, and let's just keep it sorted result. Add sorted result dot to list. Result dot add sorted result is to list. Sure, till this point that's good, but what to do now? We grabbed our first element, we have reached to a point where the other two elements are in such a way that a plus b plus c, the sum is 0. But should we just stop the execution of this two sum problem, or we continue still? Let's understand. So should we continue? If we were at minus 2, let's say we had to get to a number 0, or let's say a number 10, and we were at minus 20 and plus 30, right? Minus 20 and plus 30. Let's see. So the question now is, let's say the first element was minus 10, right? In the triplets, so the sum of the other two elements needs to be 10, because a plus b plus c needs to be 0, right? So, and this is our remaining array, the array to the right of this element. Now we reach to a point where left and right index, the value of this is minus 20, and the value, this is minus 20, and the value of this is 30. That's good. Now the question is, should we continue to move in two pointer? Should we continue our execution? So the thing is, first thing is, there will be minus 20 because duplicates are possible, but duplicates will not be useful because we do not want duplicated triplets, so these will be useless. So that's that is not what we need to continue our execution for. But what if we are going to get a higher negative number here, let's say minus 5, and a lower, so positive number here, let's say plus 15, and the sum of the two can be equal to 10, so we have to continue our execution. Okay, okay, so sure, but what should be our approach? Should we do left plus plus or right minus minus? I think this is, again, magnetism is going to play here. That is, whether you do left plus plus or right minus minus, finally we are going to grab minus 5 and minus 15. Yeah, yeah, yep, we'll see. So I'm saying we've got to the, but still we would need to continue our execution. So let's just do right minus minus. Okay, we just reduce this by minus 1. And we kept on doing this till left is little higher than right, so that our execution ends. Sure, and once we are out of the for loop, we return our result. Sorry, I have to change the function. I'll do that. 3 sum. Let me remove this function altogether where we were using brute force. Okay, so this is our different approach. Triplets. Unique triplet problem stays here. Wait, so if the key result dot add does not contain and unique triplets dot add, we'll see one more thing, this key, and this way, okay, this, the new key is not present in the dictionary, so this triplet we've not seen before, add it to the result and then add it to the hash set. Okay, it did work. We have submitted one result that resulted in TLE. Let's add it to the test cases and see if it will work. It did. Let's submit this solution and see if we should not get a TLE now. We'll say, there we go, it got submitted. Awesome. So we solved this problem, three sum, first with brute force, but that had a time complexity of n cube and that resulted in TLE. Then we went to a two sum problem with extra element and that is n squared time complexity, and that solved the problem. Thank you.